Hey girls, so we are on to 1D at the moment. Now on your sheet, on your notes, it's, I didn't write 1D at the top of the page, but we are starting with standardised scores, or Z scores. Alright, so this is 1D. So standardised scores and Z scores relate to the questions we just did in 1C with the 68, 95, 99.7% rule. But now what we are looking at comparing two different sets of data. So if we're talking about how well you did in a test, so let's say you were comparing your maths test compared to your chemistry test or whatever other subject you do. All right, now you might think, all right, how well did I do? So in my maths test, you might have got 87%, and in your chemistry test, you might have got 92%. But how do you know which one you've done better? And just because you've done got a better percentage in one, does that mean that you did better? Depends on how hard the test was. So what we need to do is we need to work out how hard the test was, and you compare yourselves to your cohort, how well you did in that test. So this depends on our mean and our standard deviation. So once we're going to do all this Z-score stuff with it, we will get a number, and that will tell us how well we did compared with the rest of the class, and whether our test was a hard one or an easy one. So what we are doing is we have got a scenario about a race. So John competes in the 800 metre race and Anne competes in the long jump. Who performed the best in their respective competitions? Now this is really hard to compare because everything's completely different in 800 metres and long jump. One's in metres, one's in seconds. Who did better? I don't know. So let's find out. So let's write down our numbers. So in the 800 metre race, oh gosh. In the 800 metre race, the mean was 3.4. The standard deviation was 0.2. John's score, or John's time, was 3.2. Now in the long jump, the median score was 4.3 metres and the standard deviation was 0.4 metres. Anne scored 5.1 metres. Who did better? We can't really tell at the moment. So what we're going to do is we're going to start off by sketching both graphs. Now both of those graphs are in your notes. Okay, I'm just going to refer to them into your notes because I'm just going to have to rub them out on my whiteboard as it is anyway. These graphs were constructed the exact same way we did in the example, or in 1C. That's our mean. Take one standard deviation, take two standard deviations, take 3, plus 1, plus 2, plus 3. When I say 1, 2, 3, I'm talking about the standard deviation, not 1, 2, 3. Alright, if you can't remember how to do this, you need to go back and revisit 1C. Okay, so once we've drawn the graphs, the next thing we're going to do is we're going to calculate our Z-scores. So our formula for a Z-score is in your notes, and it is in brackets. Brackets are extremely important in this, and I've just done mine backwards. X, take X bar, close brackets, over SD, and this will give us our Z-score. Now when we are talking about X, X is the number we have. So in this case, if we were trying to work out John's Z-score, we would be using John's time, which is 3.2 minutes, as our X. Alright, Our X bar is 3.4. And our standard deviation is 0.2. So let's do this, all right? Let's do John. All right, now I know you probably can't see green, so I'm just going to write John in green. So we put in his X as 3.2. Take away his X bar, which is 3.4, that's in brackets, over his standard deviation, which is 0.2. Put that into your calculator, and it gives you his Z-score. So John's Z-score is -1. Don't worry about what that means at the moment. You just know that's the number. All right, then we've got Anne. Anne. All right. So using the same formula, so our formula of X, take X bar, close brackets over SD. Anne's X is 5.1. Take her X bar, which is 4.3, over the standard deviation of 0.4. All right, now, oh, hang on. Oh, no, that's right. Really important when you do this that you use the X bar that relates to that person's event or that person's test or whatever it is. All right, because that's what we're comparing. We're comparing against each individual event. We're converting it to one overall score so we can compare equally. Put that into your calculator and Anne gets a score of 2. So what this means is, back to your notes. Okay, a Z-score of 0 means that the person has got the exact same number as the mean. A positive Z-score means that they are above the mean. So if we were talking about tests and the mean for a test was 68 and you got a Z-score of 2, that means that you are 2 standard deviations above the mean. If you get a negative Z-score, so the mean was 68 and you got 55, or sorry, no, you got a Z-score of -3, that means you are 3 standard deviations below the mean. All right, so that's what our Z-score tells us. How many standard deviations above or below the mean. So in this case, John is 1 standard deviation below the mean, and Anne is 2 standard deviations above the mean. So if we were talking about this, we'd be like, well, who did better, John or Anne? We would look at this and say Anne. But we need to think about this. John ran a race. Now, when you're running a race, do you want to run a lower time or a higher time? So if I'm running a race and I'm running against Monica and I ran 3.2 and Monica ran 3.5, who won the race? I did, because I finished it in 3 minutes and 20 seconds and Monica finished it in 3 minutes and 50 seconds. But if we were to graph that, I'm just going to get rid of that bit. If we were to graph that, we know I won. I bet Monica, because I did 3 minutes 20. 3 minutes 20 would be down here. 3 minutes 50 might be up here somewhere. So she's going to have a better Z-score than me because we're talking about time. But I bet Monica. So when we are talking about time, John being in the negative means that he is below. His time is faster than the mean. But Anne, who is doing the long jump, wants to jump further than the mean. So this is actually quite a confusing example, but I wanted to show you this example because now you're aware of it. If we were comparing something that you want to get as far as you can, of course you want better Z-scores. All right, I've got 20 seconds left, so I'm going to stop.